This is the CYU out of row 3. They're really highlighting the importance of knowing the relationship between central angles and inscribed angles in reference to the intercepted arcs. Okay, so we got to get the connection between these. Central angles are equal to the intercepted arcs. Inscribed angles are equal to half of. So those are the two relationships that we're going to rely on in this particular example. So let's dig into this. What they tell us, first of all, is that the measure of arc AB is 100 degrees. So I'm going to identify that in red. Arc AB has 100 degrees of angular measure. We need to find the measurement of as many possible angles as we can. The first ones that come to mind, I'm going to highlight them with these lines here, is I'm going to look for some inscribed angles that cut off that same arc from A to B. Here is one such angle. Angle 4 is cutting off this arc of 100. So therefore, angle 4, since it's an inscribed angle, has to be equal to half of that 100, so it's 50 degrees. So that's one inscribed angle relationship that I can use. Now I can start looking around for some others. Are there any other angles that go and cut off this same 100-degree arc? And yes, there's another one here at angle 7. Angle 7 does the same thing. So angle 7 cuts off the same 100-degree angle or arc, so that means angle 7 is also 50 degrees. So see how I'm using the inscribed angle relationship with the intercepted arc. Now if I try to do that with, let's say another angle here. Let's do angle 6. So if I trace out angle 6, it is not going to cut off that same 100-degree arc, so that doesn't help me on this. But the other part that we're going to bring into this is because DB, let me focus on this DB right now, that was a diameter. A diameter cuts a circle in half. And remember, a circle has 360 degrees. If we cut it in half, it has 180 degrees. So because it has 180 degrees from D all the way over here to B, if that's 180 degrees, then I can start figuring out some other angles. Remember how I had 6 highlighted? Well, 6 is still problematic because all I'm going to get is the angle from, or the arc from here to here, and I really don't have any way to determine what that arc is. So that's kind of a dead end. But let me go to the other side and we can look at this. Because over here we have this piece that goes from A to D. Now that's the other half of this circle, which is 180 degrees. So if this one's 100, then the green one has to end up being 80 degrees. And it may not look like it in the picture, but remember, oftentimes they're not drawn to scale. So that is an 80-degree angle. So what I'm going to do now is see if I have any inscribed angles that go towards that one. And I do have some. I'm going to identify angle 5. If I look at angle 5 is an inscribed angle that cuts off the arc of 80. So that means angle 5 has to be half of that 80, which is 40 degrees. Are there any other angles that cut off that 80? So I'm kind of looking around. It's not 7, it's not 6, 5. Oh, I think I found one. I think I got angle, I guess I can leave that there. Angle 2 looks like it's doing that same thing that I want it to do, and that is be an inscribed angle. So problematic moving stuff around here. Here we go. Big problems right now. So all I was trying to do is highlight that it was angle 2. So angle 2 has to be half of that as well, 40 degrees. So we're using those relationships, and you got to really search and look around high and low for them in order to get those. So those are 4 angles that we can get knowing that the arc AB is 100 degrees, and I think those are the only ones we have. So I'm going to clear that. We're going to start the second one. Given the measures that angle 1 is, so here's angle 1 is 55 degrees, and also that angle 2 is 50 degrees. They ask us to find some specific arcs, such as the arc AB. Okay, so how can we find the measure of arc AB if we're given those 2 criteria? Some of the things I'm thinking about immediately is if they give me that this inscribed angle is 50, then I know that this arc out here has to be 100 degrees. Okay, well if that's 100 degrees, then I automatically can calculate, because of our diameter, this all the way around from here to here has to be 180. So that means from A to B is 80 degrees. So I know that the arc AB is 80 degrees. The next thing I'm going to use is the fact that this was a 55-degree arc sitting here. That means its intercepted arc, which if I just move this one around right here and help you identify what I'm talking about, that means this one has to be 110 degrees or double that 55-degree angle. Because we go around half a circle is 180 degrees, this one's 110, then what's left for this arc in here, try to get a contrast in color, this has to be 70 degrees. Okay, so now they ask us for BC. So the arc from B to C is 110. The arc from C to D is 70. And now the arc from A to D has to be 100. So using your relationships between inscribed angles and central angles, this one we only had one central angle to work with, and that one central angle we had to work with were these two, if you want to think of them as 2 or 180-degree angles.